Good morning, students. In the previous class, we see some problem involving a graveness. Okay, so system of equation is given, and what problem is also given. How to solve the given problem by using a graveness rule. Now we move the next exercise. Is a Gaussian elimination method. Okay. Gaussian elimination method. We solve the given system of equation by elimination method. It may be given in 2 equations, 2 unknown, or 3 equations and 3 unknown. In a creative question, suppose you will be taking 2 equations and 2 unknown. But in your book problem fully contains all of 5 marks, 3 equations and 3 unknowns. When 3 equations and 3 unknowns is given, to solve the problem by using this method. Important, we see the method. The method is a Gaussian elimination method. How to solve? The first step, we convert the given system of equation. Okay, the given system of equation in some extended matrix form. We already see in a matrix elimination method, to convert the given system of equation is the form A is equal to B, where capital A is the values of coefficient of x, y, z in the given equations, and RHS B is a constant matrix. In the same manner here, suppose the 3 equations is given. For example, I will take the equations is x plus y minus z is equal to 5. One equation. Minus 2x plus 3y plus 5 is equal to 0. Plus 5z is equal to 0. X minus y plus 3z is equal to minus 3. Suppose, for example, I will take these 3 equations. The question is to solve these equations by this method, by a Gaussian elimination method. What is the working rule? We already did. The coefficient of x, y, z is the matrix A, and the constant is the matrix B. First, we form one augmented matrix. We already tell what is meant by augmented. Augmented means extended. The LHS matrix is A, and we include the matrix B. So this matrix is called an augmented matrix. So we form an augmented matrix. What is the augmented matrix value here? So it is a symbol of augmented A by B. You should read it as A bar B or A by B. Matrix. Okay, it's a matrix symbol A by B. A is a matrix coefficient of x, y, z in the given equations. In first equation, coefficient of x, y, z is 1, 1, minus 1. 1, 1, minus 1. And we will leave one line. You should be read it as a line or dot. Next one. So coefficient of x, y, z in the second equation. Minus 2, 3, 5. Minus 2, 3, 5. And the third one, coefficient of x, y, z in the third equation. 1, minus 1, 3. Over. We put one bar or line. Then the matrix B. The value of the matrix B is the RHS value. What is the RHS value of this equation? 5, 0, minus 3. 5, 0, minus 3. So it is a working rule of the first step. That is, by Gaussian elimination method, the given system of equation is given to form one augmented matrix. The next step, to convert this augmented matrix in echelon form. You remember the form? We already did. We converted in echelon form some row operation. For example, I say it changes 1, minus 1, 3, 5, 0, 3, 2, 6, 0, 0, 1, 5. So this form is called an echelon form. The triangle shape of an element becomes 0, and the first one is non-zero. So in this method, maximum will be changed. The first row, first column element should 1 because the simplification is easy one. So this A by B value is in echelon form. So suppose the echelon form of the matrix is this one. Next, the next step is to convert again an equation from this matrix form. How to convert? It is a value of A by B. Now we write it is in echelon form. We write the first row is a value of always coefficient of x, y, z. We don't see the given question. We check the 1, 2, 3 rows coefficients. We framing again a system of equation from this matrix equation. The first step is the system of equation is given to converted in matrix form. After we converted in echelon form, the next step using this echelon form to convert it again as some system of equation. You know very well, the first column is always a coefficient of x, second column coefficient of y, third column coefficient of z, and bar, the next one is RHS is a value of the constant. The next step, to convert this echelon form in system of equation. What is the value? 1. 1 is a coefficient of x. 1 into x is x. Next one, coefficient of y. Minus 1 into y is minus y. Third one, coefficient of z plus 3z is equal to where RHS is the constant value, that value is of 5. We frame one equation. And also you see second one. First one indicates a coefficient of x. 0 into x is 0. We leave it. Second one, coefficient of y. 3 into y is 3y. This one is a coefficient of z plus 2 into z, 2z is equal to whose exact value is 6. Second equation. Third one. First row coefficient of x, second row coefficient of y, and third row coefficient of z. 1 into z is z is equal to 5. Now we see already one value of z is there. So to use the value of z in the equation, we get the value of y. Use the value of y and z in this equation, we find the x value. So we will take the values of x, y and z. So this method is called the Gaussian elimination method. I tell again how to find the given system of equation by using Gaussian elimination method. What is the first step? To convert the given system of equation in augmented matrix form. A by B. A matrix, coefficient of x, y, z in the given system of equation by B matrix value. The value of B is RHS. The next step, to convert the augmented matrix in echelon form. Echelon form is at least minimum this triangle shape of element is 0 and the first one is a non-zero element. Here in this case it is easy to convert it is 1. So to convert it in echelon form. After in echelon form, again the matrix form into the system of equations. Maximum these two elements become vanished. So one variable value is directly there. Using the value of 1, then to find the remaining two variables. So this is the working rule to find the system of equations by Gaussian elimination method. Now you see in exercise 1.5, the first one, the first subdivision. Solve the following system of linear equations by a Gaussian elimination method. So you must see the method. The indication method only we put the sum. Suppose we put in another method, the entire answer will be wrong. So very important to careful the question. We solve the system of linear equations by a Gaussian elimination method. You see there will be 3 equations and 3 unknowns. Now to solve the equation. Solve means to find the unknown value x, y and z by Gaussian elimination method. What is the first step? To convert this system of equation in matrix form. I explained this is the first sum. The matrix form, coefficient of x, y, z in the first equation 2, minus 2, 2 minus 2, 3. Coefficient of x, y, z in the second equation. 1, 2, minus 1. Coefficient of x, y, z in the third equation. 3, minus 1, 2. Okay. Next. X, y, z is equal to the RHS 2, 3, 1. Now it is of the form AX is equal to B. So it is a value of the matrix A. It is a value of the matrix X. And RHS is the matrix B. For a convenient, I write one step extra. So the first step, the given system of equation can be written in matrix form. The next one is the augmented matrix. The augmented matrix is, we should read it as A by B or A bar B is equal to, we write first the value of the matrix A bar, next we write the value of the matrix B. So first we write the value of the matrix A, the value of the matrix A. So it is the value of the matrix A, whose values are 2, minus 2, 3, first row, 2, minus 2, 3. Second row, 1, 2, minus 1. Third row, 3, minus 1, 2. We put one bar, okay, bar. Next matrix is B. The value of the matrix B, the value of the matrix B is 2, 3, 1. 2, 3, 1. Actually it is the first step, we directly write. For a convenient, I write one extra step. So it is a value of the matrix augmented. Augmented means extended. That is, the matrix A is extended by the matrix B. What is the next step? To convert this augmented matrix in echelon form. How to convert in echelon form? The first row, first column element is non-zero. Is also non-zero. For you to change the 3 element become 0, it is very easy to convert this element become 1. Is our choice, we interchange some rows, but we do all the problem in row method. 2 minus 2, 3, 2. Suppose this number also an even number, we divide by 2. The element become 1. It is easy to convenient in echelon form to convert that element become 1 in all the problem. To the first work, to convert or to change the first row, first column element become 1. Is also an even number, divide by 2 is possible. Suppose we divide by 2, that number is become 3 by 2, one fraction. The simplification is more complicated, but you see the column 2, 1, 3. Suppose we interchange these 2 rows, 2, 1, we interchange, become 1 and 2. So it is not equal matrix, it is an equivalent matrix. So I put an equivalent symbol. Now we interchange R1 and R2. You know very well, it's R1, row 1, R2, R3. The first step I do, R1 and R2 interchange. So the symbol indicates interchange. R1 become R2 and R2 become R1. I entirely interchange these rows. So the second row become first row. 1, 2, minus 1, 3. The second row become first row and the first row become the second row. 2, minus 2, 3, 2. Now change the third row. 3, minus 1, 2, 1. So the first step, to convert the first row, first column element become 1. In echelon form, the next step, to convert this element become a 0. And then that element is also become 0. So first step over 1. The next step, to convert this element become 0 and that element is also become 0. Now you see, okay, this element become 0. You see it is R2 and it is R1. Suppose the R1 is also multiplied by 2, the element 1 become 2. 2 minus 2 become 0. So the first row is no change. In second row, how to write? R2? R2 minus 2R1. So first row is no change. We write as it is the first row. What is the value of first row? 1, 2 minus 1, 3. 1, 2 minus 1, 3. So no change. And the second row, our motive is to convert that element become 0. So we see R2 and R1. So we write R2 as R2 minus 2 times of R1. So R2 as R2 minus 2R1. So we do the process fully by R2. Now 2 minus 1 to 2. 2 minus 2 is 0. Now the next element is also very important. Now you see that element is minus 2. We write R2 as R2 minus 2 minus 2 times of whose corresponding element in R1 is also 2. Minus 2 minus 4 is a minus 6. Next 3. Next element is 3. For identification I write here 3 minus 2 times of, we write R2 as R2 minus 2 times of the corresponding element of a 3. The corresponding element of a 3 is minus 1. What is the final answer? 3 minus 2 into minus 1 is a plus 2. 3 plus 2 is a 5. Okay. Next element become, that is the next element is 2. The number 2 become, we write R2 as R2 minus 2R. 2 minus 2 times of 3. Minus 2 3s are 6. 2 minus 6. 2 minus 6 become minus 4. So second row over. Now we move the third row. What is the third row? First element 3. That element also become, we need 0. Now we see the rows of better R3 and R1 because R1 is also just 1. So how to write R3? That element is also, suppose a 3 become, we separate that element become 0. So how to write R3? We write R3 as R3 minus 3 times of R1. So we write R3 as R3 minus 3R1. 3 minus 3 ones are 3. 3 minus 3, 0. Next. Minus 1. Okay, R3 minus 1. Minus 3 of. The corresponding element of minus 1 in R1 is 2. Is 2. Minus 1. Minus 3 to 6. Minus 1 minus 6 is minus 7. Okay, minus 7. Next element is 2. We write R3 as R3 minus 3R1. 2. R3 value is 2 minus 3 times of the corresponding element of this 2 in R1 is minus 1. So minus 1. 2 minus into minus is plus. 3 ones are 3. 2 plus 3 is 5. The last element is 1. How to change 1? We write R3 as R3 minus 3R1. So 1 minus 3 times of 3 minus 3 times of 3. 1 minus 9. 1 minus 9 become minus 8. So first row, first element 1. This 2 element is become 0. The next one important, to convert this element is also become 0. We already tell, after we change this 2 element become 0, we see or we consider only the R2 and R3? Because we consider R1, one element occur here. So after we change this two element becomes 0, we consider only R2 and R3. So the first row is no change. 1, 2, minus 1, 3. And second row also no change. 0, minus 6, 5, minus 4. We do the process only in R3. Our motto is to convert this element become 0. We write R3. The value of R3 is, our motive is to convert that element become 0. We see only R2 and R3. Minus 7, minus 6. Both are the different number and also same sign. But to convert this element become 0. What is the process? We interchange the numbers. We interchange the numbers means we multiply second row fully by the number 7 and we multiply fully by the row 3 is 6. So it is the only way to convert that element become 0. Because 6 and 7, 7 is a prime number. So we interchange, in this situation we interchange the numbers. So we write R3, don't consider the first two because all are 0. So when we change the number is always 0. So we write this R3 as, okay, we interchange the number. 6 times of R3, 6 R3 and 7 times of R2. 7 R2. We insert the symbol is a plus or minus. The symbol is a minus because both have the same sign, minus. So when we separate, then only it becomes 0. So now we write fully by R3, that is row 3 as 6 times of row 3 minus the 7 times of row 2. This process only we have that element become 0. So first number is no change, is 0. That means 6 into 0 is 0, minus 7 into 0 is also 0. Now we see the second element, minus 7 is there. We write R3 as 6 R3. So 6 into R3 minus 7 times of R2. R2 is 6. R2 is 6, is a minus 6. 6 into minus 7 minus 42. Minus into minus is plus 42. So minus 42 plus 42, that value is 0. So the remaining element is very important. We write R3 as 6 R3. The element of R3 is here 5. I write briefly 6 into 5. 6 into 5 minus 7, whose corresponding element of 5 in R2 is also 5. What is the final value? 6 5s are 30 minus 7 5s are 35. 30 minus 35 is minus 5. Minus 5. This element is over. You identify the number minus 8 becomes, each and every element is important and also the sign also very important. Now the number minus 8 becomes, we write R3 as 6 R3. 6 times of, here the R3 value is minus 8 minus, okay, minus 7 times of, the corresponding element of minus 8 in R2 is minus 4. 6 into minus 8 minus 48. Minus into minus is plus 7 4s are 28. Is a minus 48 plus 28 is a minus 20. Now you see it is in echelon form. Yes, this is in echelon form. The first row, first element is 1 and at least this triangle shape of element is become 0. So now this form is called an echelon form. We write it is in echelon form. Actually it is a value of A by B. It is in echelon form. We write in the system of equations. So I directly write, we write we already tell how to write. That is the next step to convert the matrix form into the system of equations form. Actually, the part before all are the coefficients of x, y, z, and bar right hand side value is the value of the constant. So it is in equivalent form. The next step we write it. The matrix equation or the matrix form become a system of equations. Always the first one is the coefficient of x. What is the value here? 1. I write briefly. So 1 into x. The next one is the coefficient of y. The number is plus 2. So plus 2 into y. And the next one is the coefficient of z. The value of z is minus 1. So minus 1 into z. Whose corresponding value in the bar next is 3. So that value is 3. This is the first term, so I write briefly. So 1 into x is x. Plus 2 into y is 2y. Minus 1 into z is minus z is equal to 3. We use the equation, so I put it is equation 1. Is the first equation. Next, we see the second row. First value is 0. So coefficient of x is 0. So 0 into x. Next one is the value of coefficient of y. What is the value? Minus 6. So minus 6 into y. Next one is the coefficient of z plus 5 into z, whose corresponding value in that one is minus 4. So minus 4. So 0 into x is always 0. Minus 6 into y is minus 6y plus 5 into z is 5z is equal to minus 4. I use this equation also, so I put it is equation 2. Now we finish the first row, second row. Now we come in third row. First one. The first one element is 0. So 0 into x. The second one is also 0. 0 into x. The second one is the coefficient of y. 0 into y. And third one is the coefficient of z. So minus 5 into z is equal to, whose corresponding value in RHS is minus 20. So 0 into x is 0. 0 to y is 0. Minus 5 into z is minus 5z is equal to minus 20. So the value of z is minus 20 by minus 5. We cancel, we get the value of z is 5. 4. In fifth table, 20 as 4 times. I tell again, this is a equivalent form to convert it in the system of equations. So all the terms are very important. Suppose we change any one of the element or any one symbol change, the answer cannot be occur. So how to convert the equivalent form in a system of equation? First row is the value of coefficient of x, y, z, whose corresponding value is RHS. Second row is also, it is a coefficient of x, y, z value, whose corresponding value is RHS. Third row is also the same. So we find the individual value of z. Using the value of z to find the remaining two unknowns. Now we see the value of z is 4. Now we use the value of z in 1 or 2. In 1 there will be x, y and z, 3 unknowns. We have only one unknown value. You see in 2 there will be 2 unknown. Using this unknown to find another one unknown, y. So we substitute the value of z in 2. Second equation. 2 gives. Actually it is the second equation. In the second equation we use the value of this z. The second equation is start from minus 6y. Minus 6y plus 5z plus 5 Z. The value of Z is 4. Is equal to the RHS value in the second equation is minus 4. So minus 6y plus 5 4 7 20 is equal to minus 4. 20 minus 4 minus 6y plus 20 goes to RHS is a minus 20 minus 4 minus 6y is equal to minus 20 minus 4 is a minus 24. The value of y minus 24 by minus 6. The multiplication minus 6 becomes outside division. Minus by minus is plus. In 6th table 24 is exactly 4 times. So the value of y is also 4. The next step to find the value of x also. So now we use the value of y and z in 1. To substitute the value of y and z in 1, automatically to find the value of x also. The equation 1 is x plus 2y minus z is equal to 3. So in this equation, to substitute the known values. What are the known values? Y and z. So to use these two values in this equation, x plus 2, the value of y is 4. 2 into 4, minus sign is there, so minus. The value of z is also 4 is equal to 3. So x plus 2 4 are 8 minus 4 is equal to 3. So x plus 8 minus 4 is 4 is equal to 3. Plus 4 becomes the side minus. So x is equal to 3 minus 4. The value of x is minus 1. These values is called a solution. Therefore, the solutions are the value of x is minus 1. The value of y is 4. And the value of z is also 4. So it is our required solution. X value minus 1, y value is plus 4, and z value is equal to plus 4 again. For our convenience, we take a one verification. The verification means our answer is correct or not to check. Suppose we do the problem in a test or exam. You have a doubt in the given solutions. How to check? We take the given values in any one of the three equations. Is your choice, we take any one of the three equations. Suppose the equation is satisfied, our answer is correct. So in three equations, I will take one equation. The equation is 2x minus 2y plus 3z is equal to 2. I will take this equation. Or your choice will be take the another two equation also. To substitute these values. Suppose the LHS value is exactly is equal to 2, our answer is correct. 2 of x. The value of x is minus 1. 2 into minus 1. The next one is minus 2y. Minus 2 into y. The value of y is 4. Plus 3z. 3 into the value of z is 4. 2 into minus 1. Minus 2. Minus 2 into 4. Minus 8. Plus 3 4 12 is equal to 2. 12 minus 10 is equal to 12. Minus 8 minus 2 is minus 10. 2 is equal to 2. So our answer is correct. So it is a working rule to solve the given system of equation by a Gaussian elimination method. I tell again the working rule. What is the first step? To convert the given system of equation in a matrix form. That is, it is of the form Ax is equal to b. The second step, to form an augmented matrix. Augmented matrix means within a matrix symbol A by B. A is the coefficient of x, y, z matrix and B is the RHS matrix. The next work, to convert the augmented matrix in echelon form. Echelon form means the first row, first column element is a non-zero. It is easy to convert it, it is 1. And at least the triangle shape of element become 0. This element is called an echelon form. Next step, after we converted in echelon form, the next step, again we change the matrix form into the system of equations. Again the matrix form or the matrix equation become a system of equations. There will be 3 equations will be made. In the third equation, already the coefficient of x and y become vanished. So it has only z. Using the value of z to find the value of y. That is to substitute in the second equation. And using the value of y and z in first equation, we automatically find the value of x also. So these values of x, y and z is the solution. So it is a working rule to solve the given system of equation by Gaussian elimination method. The same model sum lies in the second subdivision and also one example. You must try in your home.